Hello, I'm Adam, and welcome to this Tetris publishing video on querying SQL Server. In this session, we'll be looking at more advanced ways of joining tables. Let's begin by looking at all the topics we'll be covering in this session. Firstly, we're going to look at returning all the data from one table in a join, even if there's no matching data in the other table. Then we're going to start looking at using intermediate tables in joins. This is when two tables have no direct connection. Then we'll look at how to join a table to itself, particularly to display hierarchical data. Finally, we'll look at joining on ranges of data. To begin this video, I want to take a look at a common problem that you frequently have to solve when using SQL. The issue is, how do you join two tables and show missing data, given that joins only show data that's present in both tables? To crack this problem, the first thing we're going to need is a query window to write some SQL in. I'm going to first click on the Prestige Cars database in the Object Explorer window on the left, and then click the New Query button, and finally I'm going to paste in the query we want to look at. This short piece of SQL is designed to return the make and model names from the make and model tables. This SQL contains code that you've already seen in a previous video in this series, so I'll not explain the workings of this particular piece of code again. But I'm now going to run this SQL by clicking Execute in the SSMS toolbar. You can see that the query has shown us some results. Indeed, if you look at the row counter on the bottom right, you'll see that exactly 100 records have been returned. So now imagine that you're quite sure that there are some makes that are in the make table, but that don't have any models in the models table. As the join by definition insists that any model ID must be present in both tables for the join to work, we would seem to have a problem, because the query cannot show makes for which there are no models. The answer to this conundrum is to use a different type of join. To demonstrate this, I'm going to make a small change to the query. In this updated version of the query, we're using a left outer join keyword to join the tables instead of an inner join. This keyword will return all of the records from one of the tables, the first table in the join, the one on the left of the join keyword, but only the matching records from the second table, the one on the right of the join keyword. This lets you visualize any missing information across the two tables. So let's see this in action. I'll now run the query, this time by pressing the F5 key. Let's take a look at the results. Well, a quick look at the record counter shows that there are 102 records output this time. Now I'm going to scroll down the record set returned by the query. There are two makes for which there are no models, Cadillac and Riley. As you can see, the model name column for these is null. That means no information available. This query still joins the two tables on the specified field. However, all the contents from the make table are returned, whether or not there are corresponding make IDs in the model table. This is the effect of using an outer join rather than an inner join. As this is an extremely important concept, I want to show you how it works in a slightly more visual way. This image shows you how an inner join works. It only returns data where the two datasets overlap, that is, where there are matching values in the column or columns that are used to join the tables. However, an outer join works more like this. Here all the data from one table, the top or left-hand table in this example, that is the make table, is returned by the query, and only the data from the table on the right of the join keyword, where there are matching values in the columns or columns that are used to join the tables, is returned. So that is one problem solved. I'll now close the query window. Let's look now at how to resolve another potential database problem. Suppose you have two tables that contain data that you want to display, yet the two tables can't be connected directly as they don't share any common fields. Well, SQL lets you extract data from unconnected tables, providing that you can join these tables via one or more intermediate tables. Indeed, most relational databases are designed for this to happen. The only thing you really need to know is which tables to use. Here's an example of this. Suppose that you want to find sales by country from the Prestige Cars database. There's a country table and a sales table, but neither share any common fields. However, there's also the customer table, and this can join to either of the two tables that interest you. This visualization shows you how you can join the sales table to the customer table, they share a common field, and the country table to the customer table too. Let's see this principle in practice. First, I'm going to click on the New Query button in the toolbar, and of course I'm going to make sure that we're connected to the Prestige Cars database. Then I'm going to paste in the query that we need. Finally, I'm going to execute this query by clicking on the Execute button. We have the country and sale price for each vehicle, even if there was no direct way of joining the two tables. The SQL shows you how the three tables are joined. The query returns the country from the table on the right, the country table, and the sales figure from the table on the left, the sales table, but nothing at all from the middle table, the customer table, and yet without the customer table to provide the bridge between the two tables that interest you, it wouldn't have been possible to link these two tables, which would have made it impossible to produce this data. So that's one more potential problem solved. I'll close this query window too. At the start of this video, when one of the subjects was given as joining a table to itself, you could be forgiven for wondering exactly what this means. Well, there are occasions when the data in a table is used to describe hierarchies. A classic example of this is organisational hierarchies, where various staff members report one to another. For an example of this, let's take a look at the data contained in the staff table of the Prestige Cars database. Here, as you can see, Amelia is the boss. She reports to no one. Reporting to her, however, are Gerard, Chloe and Susan. Their manager ID is Amelia's staff ID. The hierarchy then continues as the various other staff members all report to another person in the staff hierarchy. Now imagine that you want to display each staff member and the manager they report to. Firstly, we're going to need a new query window to write some SQL in, so I'll click on the New Query button in the toolbar and make sure this query is connected to the correct database. Then I'm going to paste in the SQL that we need and then run the query. Let's take a look at the results. For each staff member, you can see the name of their manager. As expected, Gerard reports to Amelia, as do Chloe and Susan. So what matters now is to see the way the query actually works. What you're doing here is using the data in the same table twice. Once to get the staff member's name and once to return their manager's name. However, this means using the same table twice in the from clause of the SQL. Then what the SQL does is to join the table to itself. This is what allows the manager ID to be used to refer back to the manager name when the second join is used. More technically, the from clause introduces the staff table and gives it an alias, st1 in this example. Then an inner join is introduced. However, this also uses the staff table. So it's used twice. However, and this is the vital bit, a different alias is used this second time. Here the second alias is st2. Then the two tables, for that's what they are to SQL Server, are joined in the on clause. This specifies that the manager ID field from the first use of the table in the from clause maps to the staff ID field of the second use of the table in the inner join clause. You separate the different references to the source table by using the separate aliases. Now, just to make the point, look at how this works schematically. Here you can see that SQL considers that this is a join using two tables, but by applying different aliases each time the same table is used, you can, in effect, join the table to itself and return hierarchical data. And now I'll close the query window, ready for the next piece of this session. There are an infinite number of ways to store data, and you'll probably one day encounter the need to analyse data in multiple tables, where you can't simply join one field in one table to another field in another table. An example of this is the sales category table in the Prestige Cars database. This small table contains a company-specific set of reference information that allows sales managers to categorize each car sold according to the sale price. Let me show you the data in this table to make things clearer. You can see that this table contains ranges of values between a lower threshold and an upper threshold, and each range corresponds to a specific description. In this particular case, I think it's easier to show you the result first and explain the SQL afterwards. So I'll begin by creating a new query window. Then I'm going to paste in the new query, and then I'm going to run the query. Finally, let me adjust the size of the query window so you can see the query in its entirety. Let's start by looking at the query output. This query applies a category description for each vehicle sold. The category description comes from the sales category table, where the price of each car is mapped to the range of values. So let's look at the query itself. This query starts by joining the sales details, stock, make and model tables. You're not actually returning any data from the stock table, but you need this table to act as a link or bridge so that you can join the model table to the sales details table. Once you have this core query in place, you can extend it by looking up the category description from the sales category table. This is where you need to use the sales price field in the sales detail table and see into which of the categories of the sales category table each car falls. This operation is carried out in the final 3 lines of SQL in the query. What this join does is to say, use the sale price field and compare it to the 2 fields, upper threshold and lower threshold, in the sales category table. If the sales price field is between the upper threshold value and the lower threshold value, then join the tables. Now, technically this is an inner join that introduces the sales category table. Then this range join introduces a new keyword combination, the between and keyword pair. This keyword combination can be used to look up a value between a lower and an upper threshold. In this case, the value in the sales price field is mapped to the range of values contained in the upper threshold value and the lower threshold value of the sales category table. You need to note that when using between and, you must always put the lower value after between and the higher value after and. Let's wrap up this video by looking at the key points that you've learnt so far. Firstly, you saw that you can use a left outer join or a right outer join to return all the data from one table and only the corresponding data from the other table. Then you saw that you can use the between and keywords to set up range joins. You then saw that you can actually link a table to itself using an inner join. This is normally used when you want to represent hierarchical information. And when joining tables to themselves, you must always use aliases to refer to what are in effect 2 table joins. To end this session, here are a few tricks and traps that you really need to remember. Firstly, left join and left outer join mean the same thing. You can use either keyword set. Secondly, right join or right outer join also mean exactly the same thing. Then you need to remember that the concepts of left and right join refer to where a table name appears in relation to the join keyword. Left means before or above, right means after or below. Finally, don't forget that you can always join on several fields if you need to. Thank you for watching. I hope that you enjoyed this short session and that it will encourage you to continue learning all about querying SQL Server. And remember, if you need a full and progressive introduction to querying SQL Server, you can always take a look at our books on this subject. These 2 volumes can help transform you from a SQL novice to an analytics maestro. To find them, just go to Amazon.com and search for Query Answers with SQL Server. Alternatively, visit your local bookstore. If you want to download the sample data that you saw in this video, as well as the SQL queries that we used, then navigate to www.tetraspublishing.com/SQL Server. Here you can find the sample data for download and practice querying it using SQL Server.